Hi everybody. I thought I'll make some videos and show it to you. This is something that we've already gone through. So I just wanted to make a quick review video for you guys and let me know if you like this or if you like the WebEx. We can do both actually. But I wanted to try this. I did this for my online classes when I taught 1408. That's Introduction to Biology. They really loved it, and I just ordered a whiteboard from Amazon. I think it's coming either next Wednesday or next Saturday, which is I think 15th or 18th. Anyway, so I can use both, okay, or I can use this, and then we can have WebEx sessions for question answers or something like that. So we'll improvise as we go. All right, so let me start. Um, so this one is the capillary um, dynamics, where you have the fluid, the blood coming from the arterial side, and then it is reabsorbed into the venual side, and the fluid is taken back. So arterial side, we can see that you can see the arrows that the water and small particles which can pass through these structures, they come out, right? Like through the pores, through the cell membrane, they can come out, and at the venial end, it comes back. So about 20 liters of fluid filters. So this is the filtration, right? So think of filtration as coffee being filtered through the coffee filter, right? So when we put the grains on top, we add water, then the smaller solutes come out along with the water, okay, into the pot, and the bigger particles like proteins and the coffee grind will just stay back in the coffee filter. It's pretty much the same principle. So that we call as hydrostatic pressure. Okay, so due to the fluid pressure against the boundary, like in here, the capillary wall, the hydrostatic pressure pushes the fluid across the capillary wall. So things are coming out. So here you can see that there is a U tube, okay, and if you push a piston, okay, right here, and this is the boundary, then things are going to come up on the other side. So this is the hydrostatic pressure that pushes the water and other solutes, small solutes, out into the interstitial space. Osmotic pressure, on the other hand, is made, or it develops due to the non-diffusible solutes that cannot cross the boundary. So mostly it is the proteins. Here we have these are the cells, I'm sorry, the proteins and the blood cells, like the erythrocytes and the white blood cells. Those are not going to pass out into the solute, into the interstitial space, so they remain in this side, right? So this is the boundary, and as this increases, that develops an osmotic pressure, right? You can see that there are a lot of solutes here and less solutes here. So due to osmosis, water goes from high concentration to low concentration of water, which means this side is hypotonic and this is hypertonic, depending on the number of solutes. So because there is more solute here, to equal that, water is going to move in this direction. So water is going to move this direction. So we call it as pushing effect and sucking effect. So here the hydrostatic pressure pushes everything out, and on this side the osmotic pressure sucks it back. So much so that out of the 20 liters which is filtered out, about 17 liters of fluid is reabsorbed. Okay, so that's the term we use, reabsorbed on the venial side. So here we call it as filtration, and here we call it as reabsorption. So the difference is about 3 liters. 20 liters minus 17 is about 3 liters. That's the 3 liters of fluid which is leaked in the interstitial space, and that is picked up by, and any leaked proteins are picked up by the lymph capillaries, okay, and taken back into the circulation. So this we already did, and we did this one too. So that was one of the major functions, one of the three major functions of lymphatic vessels, to absorb any leaked fluid or proteins or any solutes leaked into the interstitial space and taken back into the lymph capillary, right? So we did this. I hope this makes better sense to you. And I also put this picture. This is similar to what I had drawn on the board the other time. So here we can see that the hydrostatic pressure pushes the fluid out of the capillary and osmotic pressure pulls it back into the capillary, right? So hydrostatic pressure on the arterial side, if this is, here it says 5 millimeters Hg, and this is 1 millimeter Hg, I'm sorry. So I did not give you osmotic pressure of the interstitial fluid. So let's just go here and do this. So hydrostatic pressure, suppose, is 35 here, and 26 is the osmotic pressure in the arterial side. The net filtration pressure is 10 mmHg. On the venule side, hydrostatic pressure is far low because it has lost most of its fluid. So osmotic pressure is still the same. So we have a net or a negative pressure of 8 millimeters Hg. So we have 2 millimeters Hg, which is going to push the fluid back. So here it was 8, here it is 10, here it is 8. So the difference is what is accumulated here, and that amounts to about 3 liters of fluid, which is taken by the lymph capillaries. So let me stop here, and I'm going to upload this. So let me know. I'll put it in a discussion module so that you can comment on this, and I'll also put the WebEx recording that we did on Monday. And let me know. I mean, we should have both, but I'm going to start developing these modules, small modules, per chapter. I think I'll go over the physiology because anatomy, I think you should be okay with it. Or I can make like a small anatomy module, and then I will focus heavily on the physiology because that's what you really have to understand. Okay, and let me know your honest opinion about this.